In the domain of science and immense enigmas, the topic of what came before the Big Bang has stirred discussions and captivated thinkers for ages. This profound inquiry doesn't merely examine how we view the universe. It pushes the uttermost limits of human comprehension. Picture standing at the brink of existence, gazing into the vast, unsure of what previously existed. Our universe was conceived. The Big Bang occurred, signaling the beginning of time, space, and everything familiar to us. But was there a moment before this event? Could there have been silence, a state of complete stillness, before the cosmic unfolding began? And if so, was it really empty, or was there some activity even more remarkable preceding time itself? As we delve deeper into this question, science leads us on a voyage beyond the universe's inception into ideas that push the boundaries of what we know. Brian Cox, a well-known physicist renowned for discovering the wonders of the universe, proposes that something unexpected may have existed prior to the Big Bang. He challenges us to reconsider our concepts of existence and reality. In this investigation, we will dissect the hypothesis and the science, intriguing mysteries that may help describe what preceded everything we know. We'll look at theories that involve inflationary expansion, quantum shifts, dark energy, and even parallel universes. The revelations may astonish you, but additionally, they have the ability to alter how we perceive our place in the cosmos. Prepare to venture into a realm beyond imagination and scientific observation, a space where the unknowable continues to weave through the gloom. Scientists are left amazed and, at times, unsettled. Let's examine what might have occurred prior to the Big Bang and why such ideas disrupt everything we assume to be true. To comprehend what might have occurred before the Big Bang, we must first thoroughly examine what the Big Bang actually was. According to scientists, the Big Bang was the instant when the universe became incredibly dense and scorching hot, quickly expanding to begin the synthesis of matter, energy, and the fundamental forces. When we gaze into the night sky, we can see evidence of this fiery origin, galaxies moving outward from a common point in their early history. But why did this happen? And was there a period prior to this intense expansion? According to the inflation theory, there was, in fact, a time before, and it was far from empty or tranquil. Cosmic inflation posits that before the Big Bang, the universe was cold, sparse, and somewhat unstructured, resembling an enormous vacuum. But this vacuum was not completely empty. It contained a huge amount of power that drove the swift expansion of space, also referred to as inflation. It was so rapid that it laid the foundation for everything that followed, a phase of space growing at unprecedented speeds until the process slowed, allowing the energy to convert into particles, matter, and forces, ushering in what we perceive as the Big Bang. But what was that energy, and why did it cause the universe to expand so suddenly? And what stopped experts from believing that this boundless inflation may have produced individual cosmic patches going through their own version of the Big Bang? Envision a limitless sheet stretching out, forming tiny bubbles here and there. Each bubble represents a distinct universe, including ours. This concept, called the inflationary multiverse, proposes the existence of countless Big Bangs and an endless number of universes. Ours is just one among many. This staggering possibility challenges the very foundation of cosmology and forces us to ask what else lies beyond. The notion of absolute emptiness before the Big Bang is still very speculative and, based on current physics, not practically apparent. Even when stripped of all matter, energy, and radiation, without reality, there would still be nothing. Dark matter is everywhere in our universe. Dark energy, quantum fields, and invisible forces that combine to form an unbreakable fabric of somethingness, even in the most empty scenarios. Despite our hopes of removing all of these parts, new energy would still flow from an empty space, emerging from this seeming nothing. This alone confounds scientists, implying that true emptiness may not be possible. In the context of our infinite space, The universe has inherent qualities, constants, and physical laws that prevent it from ever being truly vacant. Imagine crafting a space devoid of particles, radiation, and all energy. Even in this hypothetical, vacuum, quantum fields, and physical constants would continue to exist. This suggests that the thing we refer to as nothing possesses structure, such as a phenomenon known as zero-point energy, which describes the lowest energy state of quantum fields. Under these circumstances, particles can still appear briefly and vanish, leaving behind an eerie hum of activity when there ought to be stillness. This goes against our conventional conception of a void and implies that even before the Big Bang occurred, something happened. We are just beginning to understand one of the most astonishing ideas in modern cosmology, the possibility of inflation. If inflation birthed our universe, perhaps it continues to indefinitely create new universes. Brian Cox describes a boundless, inflationary multiverse where universes are constantly forming and expanding. Imagine each Big Bang as a spark igniting a different universe, while inflation carries on in remote regions, spawning many others. This never-ending cycle introduces the idea of a fractal universe, where new universes could give rise to their own Big Bangs, each one continuing to exist independently of the rest. Because of the speed with which this happens, making more room for physicists, this notion is thrilling, yet disturbing. It suggests a multiverse that has no beginning or end and positions our universe as just a small portion of a vast, growing cosmic network. What if there is only an infinite before or after, an eternal cycle of growth and decay? Our understanding of nothingness changes dramatically when we examine it through the prism of quantum field theory. This theory suggests the universe is not merely a collection of matter drifting through space, but a vibrant lattice of energy fields that interact and result in everything we observe. These fields, akin to invisible oceans, ripple with wave-like particles that behave even in their lowest energy state. The vacuum fields are dynamic. Particles can flash into existence, gain energy, and then vanish, leaving behind a whisper of their existence. These virtual particles actually challenge the notion of a true vacuum. Imagine a universe without anything in it, no matter or radiation. Would that be pure emptiness? According to quantum theory, no. Fields would continue to fluctuate and occasionally produce short-lived particles. This unending activity in the apparent nothingness reveals that the universe never reaches zero. Instead, hidden energy bubbles up that defies emptiness. This insight raises the issue of whether energy fields spawn particles and produce matter. It's possible that matter formed the universe. Dark energy comes from this so-called nothingness, the enigmatic force, accountable for the accelerating universe's expansion, could be something that existed before the Big Bang. The fact that dark energy continues to exist could point to an ancient field predating our cosmos. Some theories suggest that dark energy comes in a stronger form. It's possible that energy caused inflation and prompted the swift expansion of space. If dark energy persists even when there isn't matter, then perhaps it shaped the circumstances that enabled our universe to come into existence. Or could it be the unseen hand behind inflation or even the origin of reality? As we consider this concept, dark energy transforms from a passive force into an aspiring architect of existence, holding secrets about the multiverse. Another alternative is found in the premise of cyclic cosmology, which posits that the universe is caught in an infinite loop of creation, destruction, and rebirth. Here, the Big Bang was not a singular event, but a single stage in an endless sequence. Our universe can expand and contract, having risen from the ashes of a previous one, collapsing and re-emerging over and over again. If this theory is accurate, there may never have been a first universe. Instead, existence is cyclical, always, changing itself. This model also alters our understanding of time, suggesting it may be circular, not linear. A universe that was born, evolved, died, and woke up incessantly would be timeless. Ripples in the form of gravitational waves in space, created by major events, provide another means of comprehending pre-Big Bang conditions. Detected gravitational waves may bring back memories from before the Big Bang itself. These signals could preserve information about a past cosmic state and provide proof that something existed before our universe. Such a discovery would be groundbreaking, possibly validating theories that point to a pre-Big Bang reality. As we pursue these inquiries, they lead us to consider concepts that test the limits of logic and time. One of the most ambitious goals in physics is quantum gravity's aim of uniting Einstein's theories of general relativity and quantum mechanics into a single theory. This fusion could change the way we think about what existed prior to the Big Bang. According to quantum gravity, space and time might not be smooth, but rather comprise tiny units at the Planck scale. These discrete structures could have been produced by the space-time fabric we know today, demonstrating that what we perceive to be continuous space and time only became apparent later. Quantum fluctuations shaped them from something more fundamentally radical. Like this, a different framework suggests that, previously, the actual Big Bang may not have included space or time as we know it. The string landscape that comes from string theory adds another layer. It implies that our universe is just one of many, each characterized by distinct physical laws and constants. Tiny, vibrating strings lie beneath each and every particle. The arrangement of these strings creates the diverse universes that this framework makes possible for infinite possible universes, each beginning with its own massive explosion and evolving independently. This implies that, in the universe, we are not the only ones, but a drop in a vast ocean of realities. Some theorists propose that our universe could have come from a black hole. The singularity at a black hole's center, where density becomes infinite, could theoretically spawn a new universe. The Big Bang may, in fact, be the result of such an event. This concept hints that black holes could be cosmic wombs that produce new realities. If true, beyond their event horizons, a black hole might lead somewhere else, another universe. Lastly, the very idea of time may be misleading. If time began with the Big Bang, then wondering what came before is meaningless. There would have been no before without time itself. Some cosmologists hypothesize that time began from a chaotic quantum state, an event in which both the past and the future were undefined, while others return to cyclic time, in which the universe lasts forever, bouncing between expansion and collapse. In this vision, the Big Bang is just one cycle among numerous others. No beginning, no end, just a cosmic rhythm. Based on some theories, one might even imagine a primordial mixture of fields and particles, bosons, quarks, and leptons, all churning in a high-energy state prior to these expansions. It's possible that these building blocks existed in a quantum foam, moving in and out of existence as a result of the uncertainty principle. This soup could provide a bridge to the time before time. Ultimately, the question of what was prior to the Big Bang is still one of the deepest mysteries of modern science. As our comprehension of space-time physics advances, our theories become more complex than the previous ones. While we may never receive a definitive response, humanity is driven by the search for this mystery, stoking our inborn desire to look into the unknown.